Welcome to the 7th and last lesson of this course. In this lesson we'll talk about how we can make single predictions using our model and how to save it. Let's go to Colab. Now we're on Colab. First we'll import the necessary libraries and import the data and create our model. Now we define our predict function. Models in Pytorch accept a batch of images at once, not single images. So we'll need to take an image and convert it into a batch using the unsqueeze function that we've talked about in a previous lesson. Now that we have our batch, we make our predictions. Then we call torch.max. We call this function on the output and store the index in a variable called preds, the index of the highest value. We set the dimension to 1 because we want the maximum value in each prediction made for an image, and in this case we only have one image. Because we have one image, preds is a one-dimensional tensor that consists of one element. We take that element and convert it into an integer using the .item method. Then we see what class does this index correspond to using dataset.classes, but this and dataset.classes contains all the classes of our dataset. We call model.eval so that our model is ready for evaluation and making predictions, because models act differently during predictions, during making predictions, and during training. We select a random image and we get the image and the label. Then we make the prediction using the image and we compare it to the actual label. So the predicted label for the image was 2 and the actual label is 9. We didn't get this correctly, but we might have got it correctly if we trained the model, but training the model is out of scope of this lesson. So now when we train models, we need to save them because we might need to improve them sometime later, or we might need to make predictions using them. So we call torch.save, we give it the model's parameters and give it a file name. So now we have the model's parameters in this file here. And if we want to use the model again in the future, we need to use the same model architecture. So we make a model with random weights at first, as we do here. Then we call torch.load on the file path, then call model.loadStateDict method of the model to load the parameters to the new model. Thank you for taking the course. It has been a nice journey learning how to use Pytorch to make deep learning models. I really enjoyed giving you this course and I'm looking forward to giving you more. If you'd like to contact me, this is my email here. And if you have any suggestions, feel free to contact me.